it is the mass is lowered with the help of a string attached to it, and that is moving downward with an acceleration of g by 4. হ্যাঁ, রেজাল্টিং অ্যাক্সেলারেশন ইজ জি বাই 4, ওয়েট তো এমজি আছে, মানে কনসেপ্টটা হয়ে গেল if this is a block of or particle of mass m, so definitely it is having its weight mg acting vertically downward, right? It is mg downward, and tension in the string, this is a string, so tension in the string that should be acting upward, because whenever we attach a string with a block, so tension in the string should be countable in the upward direction. ঠিক আছে, তো টেনশন আপওয়ার্ড এমজি নিচে, অ্যান্ড ইট ইজ মুভিং ডাউনওয়ার্ড উইথ আ রেজাল্টিং অ্যাক্সেলারেশন অফ জি বাই 4 মিটার পার সেকেন্ড স্কোয়ার. So if it is following this mechanism, and then if you think that this is lowered downward through a distance d, then what will be the work done by the tension in the string? Now we have to calculate the work done by the tension in the string. So tension in the string, which is acting in which direction? Upward in direction. So we have to calculate the work done by this tension force, which is practically acting upward in direction under the condition where block is moving vertically downward through a distance d. Taito? So whenever we know that whenever work is said to be done by a force, then we need to see the value of that force by which work done has been asked, and we also need to know the displacement of the mass along the line of the force given, right? Because whenever we will say work done is force into displacement, simply force into displacement, that means displacement must be taken along the line of force applied or force available on the mass, right? So based on this theoretical concept, the force on the mass is acting upward, so displacement should be taken not necessarily upward, along that line. It is not always necessary that displacement will always be along the direction of the force. It may be some cases the displacement along the direction of the force, in some cases may be the displacement opposite to the direction of the force, right? Here force is acting upward, but the displacement is taking place downward. That is to be taken into care, right? So do it now. The work done should be discussed using the value of the force. That is, here the work done has been asked by tension T. So do you know the value of the tension T? So that means your objective should be to know the value of the tension in the string. Though I am denoting it, I have denoted it with the symbol T, but can you just simply say T is the force value? T is the notation. T later is used to represent the tension force. Tension starts with T, so usually we write down T to represent the tension force. That is representing term, but T is not the value of that force in the string. So what will be the value of the force? Because without knowing a particular force, how can you calculate the work done by that force? No. Say, basically you should observe these two things. There are two forces acting on the mass. One is mg downward, and another one is the tension in the string. So do you think that these two forces are equal? Yes. If, for example, if I consider your understanding that if T is equal to mg, if you think that yes, T is equal to mg, so by taking T is numerically equal to mg, this showing that they are balancing forces. So when forces balances each other, Do you mean to say how can it be possible when the forces are just balancing each other? How can it be possible that this implies that when there are balancing forces means no resulting force? Will there be any resulting force or net force? If there is no resulting force, that means no acceleration, because we know that net force is equal to m into a. Since we can write down, we can understand F net force is only gives us the concept of accelerating motion. Had it been, it is possible that T is equal to mg, that means T is balancing the weight of the body. In that case, mass should not have any accelerated motion, but question saying that this mass is descending downward with this acceleration.
Hence the value is not equal.
No, that means T can never be cannot be mg here. At least in this case, T cannot be equal to mg. T will be less than mg.
Okay.
That means net force should give that possible acceleration of g by 4.
Okay.
That means here we should write down, this implies that definitely mg is greater force than T. So mg minus T should be m into that resulting acceleration, as because the resulting acceleration is given downward. So this gives a basic understanding, that is definitely the downward force is more in value than the upward force. That's why I am writing downward force minus upward force, as it is going downward. So the force in the direction of the motion will be positive, and the force appearing on it in the direction opposite to the motion will be negative. That's why T is acting upward against the motion. That's why T is taken negative. So from this part we can write down, it is mg minus T equals to m into g by 4, because value of A is given g by 4. So from this part we can write down T is equal to mg minus mg by 4. T is basically mg minus mg by 4. So this should be equal to 3 mg by 4. Are you getting it?
Okay.
T is basically numerically here 3 mg by 4, acting upward in direction. And as the body is moving downward through a displacement d, so therefore I should write down work done by tension in the string, that should be equal to T into minus d. Why I am writing minus d? Because if I take T is positive, then d is negative, opposite in direction, so negative work done. So that's why this will be minus, instead of T I can write down 3/4 of mg, that into d. So this is the work done, minus 3/4 mg d. Getting me? Minus 3/4 mg d is the value of work done by tension in the string in this case.